So finally, we kind of pull it all together. If we have a chemical reaction like the one that I have shown here, hydrogen and oxygen bonding together to form water, well, the first thing that I have to do is I've got to be able to look at a little model piece and see, be able to figure out what kind of piece I'm going to use. So I am going to use a little sphere that has just one hole in it to represent hydrogen. And the reason that I'm using the one that only has one hole versus a piece like this that has two holes in it is because hydrogen has one valence electron. And since he's got one valence electron, he needs one more to finish off his shell. So hydrogen's one of those diatomic molecules that you have to memorize. And so rather than hydrogen just showing up by himself, he shows up as a molecule that looks like this. So this H2 molecule, that's this guy right here that I've got. Okay? So one of those is going to react with one oxygen. Now, oxygen has 6 valence electrons, which means that he needs 2 more valence electrons to finish his shell. So I'm going to use the little circle sphere that has 2 openings to it. And by doing that, I can kind of see that oxygen is also a diatomic molecule. He's not just going to hang out by himself. He's actually going to bond to another oxygen molecule just like this. And so oxygen, or he's going to bond to another atom. So oxygen is going to be this. So this is this guy right here. O2 is going to be an oxygen bonded to another oxygen. And they're usually red in these kits. So this is what my oxygen looks like. And he's got 2 bonds to him. And then I've got my hydrogen, my little hydrogen guy right here. That's hydrogen. Now, when I've got those 2 guys next to each other, and I notice that I'm going to be making water out of him. So I'm going to 2 hydrogens. So there's my hydrogen. I'm going to need 2 of those guys, and they're going to bond to 1 oxygen. So here's my 2 hydrogens. He's going to bond to 1 oxygen, and so water looks like this. All right? Now we've got a little bit of a problem. If I have 2 hydrogens come out and 1 oxygen come out, I had 2 oxygens going in. So you can see that what I've got going in, these 4 atoms, are not equal to what's coming out, these 3 atoms. So that means that my equation is not balanced. And that's a problem because matter can never be created or destroyed. So I'm just going to draw the picture right here of what that looked like. And I've got that problem that matter can't ever be created or destroyed. So in order to fix that, I can see that if I've got only 1 red coming out, and 2 reds going in, I need another one of these. So I'm just going to go ahead and draw another water molecule here. And now I can see, well, when I do that, I now have 2 waters. So I put a 2 in front of H2O because I've got 2 of them now. But now my hydrogens are not balanced. So I only have 2 hydrogens going in, but now I've got 2 of these pieces, so I've got 4 total coming out. You can see here that I've got 1, 2, 3, 4 hydrogens coming out. So that means that I have to put a coefficient of 2 in front of the H2. I'm going to need to have 2 of these guys. So I'm going to make another one of him, and then I'll have a total of 4 hydrogens coming in and 4 hydrogens going out. And now I'm balanced. Matter has not been created or destroyed. Everything that went in is equal to everything that came out. So the key to remember is that these numbers right here are going to tell you how many of an atom we have. So that 2 right there tells me I've got 2 hydrogens when I make this molecule. The 2 in front is called a coefficient. That tells me I've got 2 of these whole molecule pieces.